In this episode, we're going to make Linux command output feel controllable instead of chaotic by focusing on a simple idea. Programs don't just do things, they also talk, and Linux gives you clean ways to redirect that talking. Beginners often experience the terminal as a place where text appears, errors appear, and sometimes things disappear, and it can feel like the computer is being unpredictable. The truth is that most command line programs follow a very consistent model for input and output, and once you understand the three basic streams and how pipes connect them, you start to see the shell as a plumbing system rather than a magic box. This matters for Linux Plus because questions often describe symptoms like an error message appearing even though you redirected output, or a pipeline producing nothing because the data is not flowing where you assumed. Our focus will be the concepts of standard input, standard output, and standard error, and how redirection and piping reshape those streams. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Every process on a Linux system has a set of input and output streams that it can use to communicate. Standard input, stdin, is the stream a program reads from when it expects incoming data, like a line typed by a user or data provided by another program. Standard output, stdout, is the stream a program writes to when it produces normal results, such as listing items, printing a report, or returning data meant for further processing. Standard error, stderr, is the stream a program writes to when it needs to report problems, warnings, or diagnostic messages that are not part of the normal data output. The reason Linux separates stdout and stderr is practical. It allows you to treat clean data and error messaging differently. If you're building a pipeline where one program feeds another, you usually want only the actual data to flow through the pipe, not the warnings and error chatter. Understanding that separation is the first mental step toward making redirection feel logical rather than surprising. A useful way to picture these streams is to imagine a program as a small machine with 3 ports. One port is for input coming in, and 2 ports are for output going out, one meant for results and one meant for complaints. By default, in an interactive shell, stdin is connected to your keyboard, and both stdout and stderr are connected to your terminal screen. That default makes it feel like everything is just text on the screen, but the key is that the program is actually writing to different channels even if they end up in the same place. When you redirect output, you're changing where one of those ports is connected, like moving a hose from a sink into a bucket. If you redirect only stdout, the normal results go to the bucket, but the complaints might still go to the sink, which is why you can still see errors appear. This is one of the most common beginner surprises, and it disappears once you remember there are 2 outbound streams. Redirection is the mechanism that lets you change those connections. At a conceptual level, you can redirect stdout so that instead of going to the terminal, it goes to a file or to another destination. You can also redirect stderr separately, which is useful when you want to capture error messages for review or keep them from mixing with clean output. The important beginner point is that redirection is not about changing what the program does internally. It is about changing where the program's output streams are connected. This is why you can often take a program that prints a report to the terminal and send that same report into a file without the program being aware that anything changed. In Linux Plus thinking, redirection is a core idea because it is the foundation for building command sequences, capturing logs, and managing noise during troubleshooting. The exam is less interested in whether you remember a symbol and more interested in whether you understand that output and errors are separate streams that can be handled differently. Now let's talk about pipes, because pipes are the feature that turns separate programs into a single data processing chain. A pipe connects the stdout of one program to the stdin of another program. That means the first program produces data, and the second program consumes it as if it were being typed in, even though it is coming from another program. This is incredibly powerful because it lets you build complex transformations by combining simple tools, each one doing one job well. The key conceptual point is that a pipe only carries what is written to stdout by default. If a program writes messages to stderr, those messages will not go through the pipe unless you explicitly redirect them into stdout first. This is why you can see error messages printed to the terminal even when you are piping output into another program. The system is behaving consistently. You just have two output channels, and the pipe is attached to only one of them. Once you grasp that, you can understand a common failure mode, a pipeline that seems to produce no output because the data you care about never made it into stdout. Some tools print certain information to stderr because they consider it diagnostic rather than data, even if it looks like normal text to a human. In those cases, the pipe may be receiving nothing, and the next program in the chain has nothing to process. Beginners might conclude the pipe is broken, but the real issue is that the data is on the wrong stream. Another failure mode is when error messages appear to be mixed with data in a file, which happens when you intentionally merge stderr into stdout and then redirect the combined stream. That can be the right move when you want a full transcript, but it can also be the wrong move if you need clean machine-readable output. The mental habit is to decide whether you want only results, only errors, or both combined, and then connect streams accordingly. It also helps to understand that stdin is not just for interactive typing. Many programs behave differently depending on whether they are reading from a terminal or from a pipe, and that difference can show up in buffering and formatting. For example, a program might display progress indicators when it detects a terminal, but suppress them when it detects that its output is being piped to another program. It might also buffer its output differently, causing data to appear in bursts rather than line by line. This is not the program being inconsistent. It is the program adapting to the environment it is connected to. For exam scenarios, this can matter when a question describes output appearing delayed or formatted differently in a pipeline. You do not need to become implementation heavy to understand it, because the core concept is that the presence of a pipe changes the program's relationship with the terminal. The terminal is a special device, and programs often treat it differently than they treat a file or a pipe. Another key conceptual skill is recognizing the difference between redirecting and piping, because beginners sometimes treat them as the same idea. Piping is about sending stdout to another program's stdin, which is a live flow of data between processes. Redirecting is about sending a stream to a file or another destination, which is often about storing output or suppressing it. You can combine them, such as piping data through transformations and then redirecting the final result into a file. You can also redirect at the beginning of a pipeline, such as feeding a file into a program by redirecting the file into stdin. The bigger idea is that you are building a data path, a source, a series of transformations, and a destination. Thinking in those terms keeps you from getting lost in symbols, because you can always ask where is the data coming from, where is it going, and what happens to errors along the way. Linux Plus often frames questions in terms of desired outcomes like capture output, but still show errors, which is really asking whether you understand these paths. Standard error deserves special attention because it is both helpful and sometimes confusing. It exists so that errors are visible even when output is redirected, which is a feature, not a bug, because it prevents silent failure. Beginners sometimes redirect output to a file and assume everything is fine because the file exists, but errors printed to stderr can tell a different story. On the other hand, there are times when you want to capture errors as part of a diagnostic transcript, such as when you want to review what went wrong later. This is where the concept of merging streams matters, because you can intentionally combine stdout and stderr so they travel together. The caution is that once merged, the distinction is lost in the combined output, which can make later processing harder. The exam may not demand you recall every symbol, but it does expect you to know that errors can be separated or combined, and that the choice has consequences. Pipes also introduce an important idea about failure and visibility. A pipeline can succeed in part and fail in part, and the symptoms depend on where the failure occurs. If the first program fails and produces no output, everything downstream has nothing to do. If a middle program fails, it might stop consuming input, which can cause upstream programs to behave differently, sometimes even causing them to terminate early because the pipe is no longer being read. This can feel confusing at first, but it is a natural result of connecting programs together with finite buffers and flow control. The key beginner lesson is that a pipeline is a chain of dependencies, and each link affects the others. When a pipeline produces unexpected results, you can often diagnose it by thinking about where data might have stopped flowing and whether errors were printed to stderr instead of being carried onward. For Linux Plus style reasoning, this becomes another application of the troubleshooting chain mindset, but applied to data flow rather than network layers. There is also a subtle but important conceptual point about what it means for output to be data versus presentation. Many programs format output for humans when writing to a terminal, adding spacing, color, or headers that look nice but are not ideal for feeding into another program. When output is piped, some programs adjust and produce a more machine-friendly format, while others do not. This can cause a beginner to think the tool changed its output randomly, but again it is often reacting to whether it is connected to a terminal. The lesson is that the shell environment influences output style, and pipes change that environment. When exam questions mention that output differs when redirected or piped, the correct reasoning is to suspect terminal detection and stream behavior. You do not need to know every special case, but you should know the general principle that the same program can behave differently depending on where its streams are connected. To make all of this practical in your head, you should be able to narrate a simple story of data flow for any command sequence you see. A program reads from stdin, writes normal results to stdout, and writes problems to stderr. By default, those outputs go to the terminal, but redirection can send either stream to a file or other destination. A pipe sends stdout of one program into stdin of the next, creating a live chain of transformations. Errors do not flow through the pipe unless you intentionally merge them, which is why you can see messages even when you think you redirected everything. When you view it as a set of hoses connected to ports, the symbols become less intimidating because you are just deciding which port goes where. That is the core skill Linux Plus is building, because it supports everything from simple troubleshooting to building reliable command line workflows. By the end of this episode, the main takeaway is that redirection and pipes are not special tricks. They are straightforward ways to control the three standard streams every program uses. stdin is where input comes from, stdout is where normal output goes, and stderr is where error and diagnostic messages go. Redirection changes the destination of a stream, and piping connects one program's output stream to another program's input stream. Most confusion comes from forgetting that there are two different output channels and assuming all text on the screen is the same kind of output. Once you keep the streams distinct in your mind, you can predict what will happen before you run anything, and you can interpret exam scenarios accurately because you know which stream is being redirected or piped. This mental model makes the shell feel like a system you control, and that feeling of control is what turns a beginner into a confident Linux troubleshooter.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.